Hello, in this video we'll be discussing ionic bonds. So let's not waste any of your time, let's get right to it. Now when we're talking ionic bonds, we are talking about bonds to where the electrons are taken or gained based on the strength level, the electronegativity level of an atom. And this whole process, just like all bonds, it's the idea to fill the outer shell. Now, if you are gaining electrons, you're adding to your basket of electrons. So you're looking to get to 8 by adding, increasing your number. If you are losing electrons, in a sense, you're getting rid of all the electrons on your outer shell, and when you fall back to an inner shell, it's already full. So you'll fall back, you'll meet the octet rule in that manner. But you can see in our diagram, atom 2 or atom B, it has 7 valence electrons on its valence shell. And atom A, or the first atom, has 1. And so what happens? The atom B will physically pull away the electron from atom A, and an atom B now has a full outer shell, and atom A will fall back to an earlier or a closer ring that is already full and meet the octet rule in that manner. So that's the idea of an ionic bond, the gaining or taking or losing electrons. And when that happens, if you gain an electron, you are a negative ion or an anion. If you lose an electron, you are a positive ion or a cation. And again, those references are, do you have more protons than electrons, or do you have more electrons than protons, since they are positively or negatively charged? Now in this diagram, and again, if needed, if you've had a chemistry class and you were solid in this, then I wouldn't worry about it. You'll have no trouble with any quizzes or test questions. But if this information is new to you, maybe the diagrams will be of help to you. But as it says, if you do decide to draw the diagrams, please only do the valence shells. You do not need all the inner shells to understand this concept, and that will just add a tremendous amount of time and energy on your part. So just do the valence shells. That is where all the action is that we're looking at. But if we look at the first one, the first bond, we've got a sodium and a chlorine, and this is your typical salt example that you'll see with an ionic bond. But the chlorine has 7 valence electrons, and the sodium has 1 valence electron. So the chlorine takes the electron, and it now has 8, and then the sodium loses the electron, so that valence shell becomes inactive, and now it falls back to an earlier ring which has 8 on it, already full. If we look at our second example, we now have magnesium and oxygen. Oxygen has 6 valence electrons. Magnesium has 2. We're trying to get to the octet rule. Oxygen, this is an easy fix. I add those 2. I now have 8. Magnesium loses its 2 valence electrons, and that shell becomes inactive. And now we're looking at a shell that already has 8 on it. So both atoms meet the octet rule, one by addition, one by subtraction. Again, if we look at our third example, this comes back to a 7 and a 1. The 7 takes the 1. It becomes 8. The lithium valence shell becomes inactive, and now it falls back to the first shell, which has 2, which is full, and that's how both meet the octet rule. Our Our fourth example is one we typically have seen where one atom takes from one and meets the octet rule, or one atom takes two from one. But now we're looking at one to where the sulfur needs two, but it doesn't find a partner that has two. It finds partners that has one and takes one from each of them. But the same concept, it goes from 6 to 8, and the lithiums lose their valence electron, which it becomes, their valence shell becomes inactive, and now they're down to the first ring, which is full. So everybody meets the octet rule, some by gaining, some by subtracting or losing. Yeah, but that is the essence of ionic bonds. Well, that's our ionic bond video. In our next video, next time we come together, we'll be discussing hydrogen bonds. So we'll see you then.